Hello, and welcome to ThinkSleep, where curiosity slows down to the rhythm of rest, and big questions become gentle companions for the night. Tonight, we're not going to talk about whether we're alone in the universe, or whether intelligent life exists somewhere out there among the stars. Instead, we're going to ask something quieter, something that sits a little closer to home but reaches just as far into the unknown. What if Earth, this small blue world spinning through space, has already been visited? Not once, but many times. Not by conquerors or colonizers, but by travelers, observers, scientists from civilizations so far away and so long ago that we might never know they were here at all. The galaxy is home to somewhere between 100 billion and 400 billion stars, depending on how you count. Many of those stars are older than ours, many have planets, and while we don't yet know how common life is, or how often it becomes intelligent, the sheer scale of time and space suggests that we're probably not the first. If intelligence arose even once in the early galaxy billions of years ago, that civilization would have had an unimaginable amount of time to grow, explore and spread. They could have visited 1 million worlds. They could have catalogued life on planets that no longer exist. They could have left markers, messages, or simply moved on. Their story finished long before ours began. And if one civilization could do that, why not dozens? Why not hundreds? The galaxy is old enough, large enough, patient enough to have hosted countless rises and falls, each one blooming in its time, reaching outward, perhaps touching Earth, and then fading back into the silence of deep time. This is the backdrop against which we ask our question. Not whether aliens exist somewhere out there, but whether they have been here, walking or floating or observing, while Earth was young, while it was empty, or while it was just beginning to fill with the earliest sparks of life. If they came when Earth was covered in shallow seas and stromatolites, would they have stayed long? If they came during the age of the dinosaurs, would they have marvelled at the size of the creatures, the strangeness of a world ruled by reptiles? If they came during the ice ages, would they have seen potential in the small, clever mammals huddling in caves? Or did they come earlier still when Earth was molten, or later, when humans had just learned to paint on walls and wonder at the stars? We don't know. But the scale of galactic time means that the window for visitation is vast. Earth has been here for 4.5 billion years. It has been a living world for most of that time, and during all those eons, the galaxy around it was full, busy, turning with the light of older suns and the possibilities they carried. If anyone was exploring, if anyone was curious, Earth would not have been hard to find. It sits in a relatively calm part of the galaxy, not too close to the chaotic centre, not too far out in the sparse edges. It orbits a stable, long-lived star. It has water, an atmosphere, a magnetic field. By any reasonable measure, it's a nice place to visit. And if you were a civilization with the means to travel between stars, with the curiosity to see what else was out there, wouldn't you stop by a place like this? Wouldn't you at least take a look? The question isn't whether Earth is special, it's whether Earth is interesting. And for a species capable of crossing the vast dark between stars, a living planet would almost certainly qualify. So here we are, late arrivals to an ancient galaxy, looking around and asking if we're the first ones to notice this place. And the more we learn about the age and scale of everything around us, the less likely that seems. But if others came before us, why don't we see them? Why aren't there ruins, relics, or messages carved into stone? Why does the world seem so untouched, so purely the product of nature and time? That's the puzzle we're stepping into now, slowly, carefully, with no rush to solve it, only to explore it. Because absence of evidence is not the same as evidence of absence. And sometimes the most interesting questions are the ones where silence is the loudest answer. There's a famous question in science, one that gets asked whenever people start thinking seriously about life beyond Earth. It's called the Fermi paradox, named after the physicist Enrico Fermi, who supposedly asked it during a casual lunch conversation in 1950. The question is simple and unsettling. If the universe is so old and so vast, and if intelligent life is even remotely common, then where is everybody? Why haven't we seen them, heard from them, or found any trace of their existence? It's a good question. The galaxy should be teeming with civilizations if life arises easily, and intelligence follows naturally. There has been plenty of time for someone to spread across the stars, to build networks of communication, to leave their mark on the cosmos in ways we couldn't possibly miss. And yet, When we look out into space, we see nothing. No megastructures. No radio signals that aren't natural. No obvious signs of engineering on a galactic scale. Just stars, gas, dust, and silence. This absence has led to many proposed solutions. Maybe life is rarer than we think. Maybe intelligence is a fluke. Maybe civilizations destroy themselves before they can spread. Maybe they're out there but hiding. Or maybe they're so advanced we wouldn't recognize their technology if we saw it. Each explanation has its appeal, and none can be ruled out entirely. But there's another way to look at the paradox, one that flips the question around and asks it from a different angle. What if they have been here? What if the silence isn't because no one is out there, but because we're looking for the wrong kind of evidence? What if contact or visitation doesn't look the way we imagine it? We expect aliens to announce themselves, to make their presence obvious, to leave behind something unmistakable, a monument, a message, a beacon that says we were here. But what if that expectation is wrong? What if visitation is quieter than that, more subtle, more careful? Think about how we explore. When scientists go to study a remote ecosystem, they try to minimize their impact. They observe, take samples, record data, and leave as little trace as possible. The goal is to see the place as it is, not as it becomes after we've disturbed it. Now imagine a civilization millions of years more advanced than ours, with ethics shaped by eons of experience, with an understanding of ecology and development that we can barely conceive. Would they stomp around leaving giant footprints? Or would they tread lightly, taking care not to interfere, not to contaminate, not to disrupt the natural unfolding of life on a planet still in progress? If the latter, then the evidence of their presence might be minimal by design. A few readings taken from orbit, a probe that landed, collected data, and left. A brief visit to observe and then move on. They might have rules about contact, protocols about interference. They might believe, as some of our own scientists and philosophers do, that emerging civilizations should be allowed to develop on their own, free from outside influence. This idea is sometimes called the zoo hypothesis, the notion that Earth is being watched but not touched, observed from a distance like animals in a sanctuary. It's speculative, of course. We have no proof that this is happening or has ever happened, but it shifts the frame of the question. Instead of asking why we don't see aliens, we ask whether we would even recognize their presence if they were trying not to be seen. And that's a much harder question to answer, because if someone wanted to visit Earth without leaving a trace, they probably could. They could stay in orbit, use instruments sensitive enough to learn everything they needed without ever landing. They could send robotic probes, small and careful, that would degrade over time and leave nothing behind. They could observe from a distance, log their findings, and move on to the next world, the next star, the next question. And if multiple civilizations did this over billions of years, each one coming at a different time, each one with its own reasons and methods, the result might be exactly what we see now. A planet that looks untouched, because it mostly was. A world shaped by its own processes, its own life, its own story, with only the faintest hints, if any, that others once paused to watch. This doesn't mean the Fermi paradox is solved. It just means the paradox might be based on assumptions that don't hold. We assume contact would be loud, obvious, lasting. But what if it's none of those things? What if the galaxy is full of travelers who visit quietly and move on, leaving the worlds they find to their own futures? If that's the case, then the silence isn't empty. It's full of respect, patience, and a kind of cosmic courtesy we're only beginning to imagine. Of course, this raises another question. If beings from other worlds came here, why would they bother? What would bring them across the immense distances between stars just to look at a planet like Earth? What could we possibly offer that would justify the effort, the energy, the time? That's what we'll explore next, not with certainty, but with curiosity. Because understanding why someone might visit is the first step toward imagining what they might have left behind. Imagine you are part of a civilization that has mastered interstellar travel. You have ships, or probes, or some means of crossing the light years between stars. You've mapped your local neighborhood, maybe hundreds or thousands of star systems. You've seen gas giants and barren rocks, ice worlds and lava spheres. And then, one day, your instruments detect something different. A planet in the habitable zone of a stable star, liquid water on the surface, an atmosphere rich in oxygen, biosignatures, complex chemistry, the telltale signs of life. Would you keep going, or would you stop to take a closer look? The answer for any curious species seems obvious. Life is rare. As far as we know, it might be extraordinarily rare. We found thousands of exoplanets, but only a handful that might be remotely habitable, and none yet where we've confirmed life. If another civilization went through the same search, the same slow process of scanning distant stars and analyzing faint signals, a living planet would be a treasure. Not because it has resources they couldn't find elsewhere. The galaxy is full of minerals, water, energy, but because it has something truly unique. It has biology. Life is interesting. It's complex, unpredictable, creative. It evolves, adapts, fills every niche it can find. It turns sunlight into sugar, breaks down rock, builds reefs, digs burrows, and eventually, sometimes, it starts to think. For a scientific civilization, a planet like Earth would be a laboratory, a living museum, a chance to see how life unfolds under conditions different from their own. They might want to study our biology, catalogue our species, understand our ecosystems, not to exploit them, but to learn from them. This is one reason they might come: scientific curiosity, the desire to see what's out there, to understand how common or rare life is, to compare notes with the universe. If they visited Earth 1 billion years ago, they might have found oceans full of single-celled organisms, vast stromatolite reefs, and little else. If they came 500 million years ago, they might have witnessed the Cambrian explosion, that sudden flourishing of complex life forms. If they came 65 million years ago, they might have been here when the asteroid struck, watching from orbit as the age of the dinosaurs came to an end. Each visit would offer something different. Each snapshot of Earth would tell a piece of the story of how life develops, how it survives, how it changes. And if a civilization visited more than once, over millions or billions of years, they could watch that story unfold in slow motion. They could see patterns, test theories, compare Earth's path to other worlds they've studied. They could build a database of living planets, a galactic encyclopedia of biology, and Earth would be one entry among many. But curiosity isn't the only reason to visit. There's also navigation. If you're traveling between stars, you need waypoints, places to stop, places to refuel or repair or simply rest. Earth sits in a relatively empty region of space, far from hazards, with a calm and predictable sun. It has water, which might be useful for certain kinds of propulsion or life support. It has a strong magnetic field, which could serve as a landmark for navigation systems. It's stable, old, and easy to find. For a civilization that roams the galaxy, Earth might be a rest stop, a place to pause on a longer journey. They might not even land. They might just orbit for a while, repair what needs repairing, gather what they need, and leave. Or they might set up something small and temporary, a research outpost, a relay station, a marker for others who come later. Something that serves a purpose for a time and then gets dismantled or abandoned when it's no longer needed. Over billions of years, dozens of civilizations might have done this, each leaving a little less behind than the last, until nothing remains but faint anomalies we'd never think to attribute to intelligence. There's another possibility, darker but not implausible: refuge. A civilization fleeing disaster, looking for a safe harbour, a place to hide or heal or start again. Maybe their home star went supernova. Maybe their planet became uninhabitable. Maybe they lost a war or faced a plague or simply exhausted their resources. Earth, young and full of life, might have looked like hope. They might have stayed for a while, watching, waiting, trying to decide if this world could be a new home. And then, for reasons we'll never know, they left. Or they didn't leave, but faded. Their numbers too small to sustain themselves, their story ending quietly under skies they'd travelled so far to see. We imagine aliens as powerful, advanced, unshakable, but they might have been fragile too. They might have been desperate. They might have come here not out of strength, but out of need. And if they did, what kind of traces would desperation leave? Would they have had the luxury of being careful, or would survival have forced their hand? These are the questions that pull us deeper, not into answers, but into possibilities. Each reason for visiting creates a different kind of story, a different kind of evidence, or lack of it. And layered together, over deep time, they paint a picture not of a single visit, but of many, each one brief, each one intentional, each one dissolving into the background of Earth's long and patient memory. But even if all of this is plausible, even if we can imagine why they'd come, we still face the central problem. Where's the proof? Where are the artifacts, the structures, the undeniable signs that someone else was here? Why does Earth seem so thoroughly, so stubbornly untouched? That's the question we turn to next, not to answer it, but to understand why it's so much harder than it sounds. Here's the uncomfortable truth. If a civilization visited Earth even just a few million years ago, we might never find proof. Not because they were trying to hide, but because the planet itself is very, very good at erasing things. Earth is not a static museum. It's a dynamic, churning, living system that constantly recycles its surface, buries its past, and grinds everything down into raw material for the future. Mountains rise and crumble, oceans open and close, continents drift, collide, and split apart. And through all of this, the traces of anything temporary, anything not designed to last geological timescales, simply disappear. Let's start with something we understand: human artifacts. We've only been around as a technological species for a few thousand years, and already we know how fragile our creations are. Leave a building alone for a century and nature starts to reclaim it. Roots crack foundations, water seeps into walls, metal rusts, wood rots. In a few hundred years, a structure that once seemed permanent is barely recognizable. In a few thousand years, it's rubble, and in a few million years, it's gone entirely, absorbed back into the soil, covered by sediment, or swallowed by the slow movement of tectonic plates. We have examples of this on a smaller scale. Ancient cities that were lost and then rediscovered, buried under meters of earth or sand. Pompeii, preserved by volcanic ash. Angkor Wat, consumed by jungle. These places were abandoned for only a few hundred or a few thousand years, and they were already nearly invisible. Now stretch that timescale out by a factor of 1,000, or 10,000, or 1,000,000. What survives? Not much. The fossil record teaches us this. Fossilization is incredibly rare. Most living things die and decompose completely, leaving nothing behind. For something to become a fossil, it needs to be buried quickly, in the right kind of sediment, under the right conditions, and then it needs to stay buried, undisturbed, for millions of years. And even then, it needs to be found. The odds are staggeringly low. Most species that have ever lived left no fossils at all. We know they existed only through indirect evidence, through gaps in the evolutionary tree or through the fossils of things that ate them. If organic material, which is designed to interact with the environment, rarely survives, what about inorganic materials? What about metal, plastic, glass, ceramics, the stuff we build our technology from? Surely those would last longer. And they do, for a while, but not forever. Most metals oxidize, iron rusts into powder, aluminum corrodes, copper turns green and flakes away. Plastics, which we think of as nearly indestructible, break down under sunlight, heat, and microbial action. In a landfill, buried and protected, they might last thousands of years. Exposed to the elements, they last far less. And over millions of years, even the most durable synthetic materials degrade into molecules indistinguishable from natural compounds. Ceramics and glass last longer. They're chemically stable, resistant to weathering, but they're also brittle. They shatter, they crack, they get ground into sand. A glass bottle left on a beach might last 10,000 years, but in 100,000 years it's sand again, mixed with all the other sand, with no way to tell it was ever anything else. And 1,000,000 years, forget it. Unless it was buried in exactly the right place, in exactly the right way, it's gone. Then there's the issue of location. Most of Earth's surface is ocean, about 70%, and most of the ocean floor is geologically young, constantly being created at mid-ocean ridges and destroyed at subduction zones where tectonic plates dive back into the mantle. The oldest ocean floor is only about 200 million years old. Everything older than that has been recycled. So if a civilization landed in the ocean or left something on the ocean floor, it's almost certainly gone now, pulled down into the Earth's interior and melted back into magma. On land, the situation is only slightly better. Erosion is relentless. Wind, water, ice, and time wear down everything. Mountains that once stood kilometers high are reduced to hills, then to plains, then buried under new sediment from somewhere else. River valleys shift. Deserts become forests. Forests become deserts. The surface of the Earth is not stable over millions of years. It's constantly being reshaped, repainted, written over. And anything sitting on that surface, anything not actively maintained, eventually gets buried, broken, or worn away. So let's imagine, just as a thought experiment, that a spacecraft landed on Earth 10 million years ago. Let's say it was made of advanced materials, alloys we don't have, composites designed to last. Let's say it stayed for 100 years, then left, but left behind a small research station. What happens to that station? For the first few thousand years, not much. It weathers. It gets covered in dust, in vegetation, in the slow accumulation of organic material. If it's in a wet climate, it gets overgrown. If it's in a dry climate, it gets sand blasted. But the basic structure is still there, still recognizable. But give it 100,000 years. Now the structure is collapsing. The elements have worked their way in. The metal, if there is metal, is corroding. The joints are failing. Parts of it are buried under meters of sediment. It's harder to see, harder to recognize as artificial. 1,000,000 years. Now it's rubble. The materials have degraded to the point where they're chemically altered. The structure is gone. What's left is scattered, broken, mixed with natural rock and soil. If you found a piece of it, you might not recognize it as technology. You might think it's an odd mineral formation, a strange nodule, something geological, and you'd move on. 10 million years, there's nothing left that you'd call an artifact. Maybe, if you're very lucky, there's a faint chemical signature in the rock, an unusual concentration of certain elements. Maybe the isotope ratios are slightly off, not quite what you'd expect from natural processes. But without context, without a reason to look for it, you'd never notice. And even if you did notice, you'd probably explain it as something natural. A meteor impact, a hydrothermal vent, a quirk of local geology. This is the problem. Not that evidence doesn't exist, but that it degrades, disperses, and becomes indistinguishable from everything else. And the longer the timescale, the worse the problem gets. After 100 million years, even the most durable materials are gone. Even intentional markers, things designed to last, would be incredibly difficult to find. And anything not designed to last, anything left casually or accidentally, wouldn't stand a chance. So when we ask why we haven't found evidence of alien visitation, the answer might be simpler than we think. We haven't found it because it's not there anymore. Not because it was never there, but because the Earth has had millions or billions of years to erase it, and Earth is very, very good at what it does. It takes everything eventually and turns it back into itself. Rock into sediment, sediment into rock, metal into rust, rust into soil. And anything that once was artificial, once was purposeful, once was a sign that someone else was here, becomes just another layer in the endless turning of the planet's memory. This doesn't mean we should stop looking. It just means we need to be realistic about what we might find and how hard it will be to recognize. Because if the traces are there, they're not going to be obvious. They're going to be subtle, ambiguous, and easily mistaken for something natural. And that brings us to the next question. If we can't find ships or buildings or tools, what can we find? What kinds of traces might actually survive, and where should we be looking? Those questions don't have easy answers. But they're worth asking slowly, carefully, with no rush to conclusions. Because sometimes the absence of something tells its own kind of story, and sometimes the hardest evidence to find is the evidence that was never meant to be evidence at all. Before we go any further, it's worth pausing to acknowledge something that's probably already crossed your mind. The idea that Earth has been visited by extraterrestrial civilizations is not new. It's been around for decades, popularized by books, documentaries, and television shows that claim ancient monuments, religious texts, and unexplained artifacts are proof that aliens were here long ago, guiding human development, teaching us technology, maybe even engineering our species. These are the ancient astronaut theories, and they have a large and passionate following. They point to the pyramids of Egypt and ask how primitive humans could have built something so precise without advanced tools. They point to the Nazca lines in Peru and ask why ancient people would carve enormous figures into the desert unless they were meant to be seen from the sky. They point to stories in religious texts, descriptions of flying chariots and beings descending from the heavens, and suggest these are accounts of actual encounters with visitors from other worlds. It's compelling, it's exciting, and it offers a simple explanation for things that feel mysterious. If something seems too advanced, too precise, too strange to have been made by ancient humans, then maybe it wasn't. Maybe someone else helped. Maybe we had teachers we've forgotten, mentors who came from the stars and left before we could write down their names. But here's the problem. Mainstream science, by and large, doesn't accept these claims. Not because scientists are closed-minded or afraid of new ideas, but because the evidence doesn't hold up under scrutiny. When you look closely at the pyramids, at the engineering techniques, at the tools that have been found, at the records left by the people who built them, it becomes clear that humans were capable of this work. It was difficult, yes. It required organization, skill, and immense labor. But it didn't require alien intervention. The same is true for the Nazca Lines, for Stonehenge, for the statues of Easter Island. These are remarkable achievements, but they're human achievements, made with human hands, human ingenuity, and human determination. The ancient astronaut theories often underestimate what humans can do. They assume that people in the past were less intelligent, less capable, less creative than we are now. But that's not true. Anatomically, modern humans have been around for at least 200,000 years, and our brains haven't changed much in that time. The people who built the pyramids were just as smart as we are. They just had different tools, different knowledge, and different priorities. When you stop assuming they needed help and start looking at what they actually accomplished, the mystery dissolves, not into disappointment, but into admiration. There's also the issue of methodology. Ancient astronaut theories tend to work backward from a conclusion. They start with the assumption that aliens visited Earth, and then they look for evidence that fits that assumption. When something doesn't fit, it gets ignored or reinterpreted. When something does fit, even loosely, it gets highlighted as proof. This is the opposite of how science works. Science starts with observations, builds hypotheses, tests them rigorously, and discards the ones that don't hold up. It's slow, careful, and often frustrating. But it's the best method we have for distinguishing what's true from what we want to be true. That said, and this is important, rejecting ancient astronaut theories doesn't mean rejecting the possibility of extraterrestrial visitation altogether. The two are not the same thing. You can believe that ancient humans built their own monuments and still wonder whether Earth has been visited at other times, in other ways, leaving traces we haven't recognized yet. The difference is in how you approach the question. Do you start with curiosity and follow the evidence wherever it leads, or do you start with a conclusion and look for anything that supports it? Science resists ancient astronaut theories not because the idea of alien visitation is inherently impossible, but because the specific claims made by those theories don't stand up to examination. The evidence is misinterpreted, the logic is flawed, and the explanations ignore simpler, more plausible alternatives. But that doesn't mean the broader question is settled. It just means we need to ask it differently, more carefully, with more rigor and less certainty. There's also a cultural issue here, one that's worth mentioning even if it makes some people uncomfortable. Many ancient astronaut theories focus on non-European cultures, the Egyptians, the Maya, the Inca, the indigenous peoples of the Americas, and they suggest that these cultures couldn't have achieved what they did without outside help. But they rarely say the same thing about Greek temples or Roman aqueducts. This double standard, intentional or not, implies that some civilizations were less capable than others, that some needed help while others didn't. And that's not just bad science. It's also disrespectful to the people who actually did the work, who built the wonders we still marvel at today. So when we talk about the possibility of extraterrestrial visitation, we have to be careful. We have to separate genuine scientific curiosity from pseudoscience. We have to give credit where credit is due. And we have to be willing to say, I don't know, without filling the gap with speculation dressed up as fact. That said, the question remains open. Just because the popular theories are flawed doesn't mean the underlying possibility is ruled out. It's entirely plausible that Earth has been visited by other civilizations. It's plausible that they left traces we haven't found yet, or that we've found but misinterpreted. It's plausible that the universe is full of travelers, explorers, scientists who pause at interesting worlds and then move on. But if we want to take that possibility seriously, we have to hold it to the same standards we hold everything else. We have to look for real evidence, not convenient patterns. We have to ask hard questions, not easy ones. And we have to be comfortable with uncertainty, with not knowing, with holding space for mystery without rushing to fill it. Science isn't about closing doors, it's about opening them carefully, one at a time, and looking at what's actually inside. And right now, the door to extraterrestrial visitation is still open. It's just not as wide as some people think, and the view through it is murkier than anyone would like. But that's okay, because the goal isn't to believe, it's to understand, and understanding takes time, patience, and a willingness to be wrong. So with that in mind, let's set aside the ancient astronaut theories and focus on the real question. If civilizations did visit Earth, if they came and went over millions or billions of years, what kinds of traces might they leave that would actually survive? What could we look for that wouldn't require us to rewrite history or ignore what we already know? What would be subtle enough to hide in plain sight but distinct enough to eventually be recognized? That's where the science gets interesting. Not in the grand claims, but in the quiet details. Not in the obvious, but in the nearly invisible. Because if the evidence is out there, it's not going to announce itself. It's going to whisper. And we'll have to listen very, very carefully. If a visiting civilization wanted to leave something behind, intentionally or not, what would that something look like after millions of years? We've already established that physical artifacts, ships, buildings, tools are unlikely to survive intact. But there are other kinds of traces, subtler ones, that might persist even when the objects themselves are long gone. These are sometimes called technosignatures, markers of technology, of intelligence, of processes that don't occur naturally. And while we usually think of technosignatures in the context of detecting distant civilizations through their radio signals or megastructures, the same concept can be applied to our own planet's past. A technosignature doesn't have to be a message or a monument. It can be a chemical anomaly, an unusual isotope ratio, a concentration of elements that shouldn't be where they are. It can be a structure in rock that's too regular, too geometric, too precise to have formed through natural processes. It can be a magnetic signature, a pattern of heat, a layer of sediment that doesn't match the layers around it. These are the kinds of things that might survive when everything else is gone. Not because they're indestructible, but because they're part of the geological record, and the geological record, incomplete as it is the longest lasting archive we have. Let's start with isotopes. Isotopes are versions of the same element with different numbers of neutrons. Most elements have several isotopes, and they occur in predictable ratios in nature. Carbon, for instance, has 3 main isotopes: carbon-12, carbon-13, and carbon-14. Those ratios stay relatively constant unless something disturbs them. Biological processes prefer lighter isotopes, so living things tend to have more carbon-12 than you'd expect. Industrial processes, like burning fossil fuels, shift the ratios in different ways. If you look at ice cores or sediment layers from the last few centuries, you can see the fingerprint of human activity written in carbon isotopes. Now imagine a visiting civilization used fusion reactors or antimatter engines or some other advanced power source. These would produce isotopes that don't exist naturally on Earth, or they'd shift the ratios of existing isotopes in unusual ways. If they stayed for any length of time, if they refueled, repaired, or simply ran their systems, they might leave a faint isotopic signature in the surrounding environment. Over time, that signature would disperse, dilute, mix with natural materials. But if it was strong enough, if the civilization stayed long enough, there might still be a trace in the rock, a thin layer where the numbers don't quite add up. The problem, of course, is distinguishing this from natural processes. Earth has plenty of its own isotopic anomalies, created by volcanic activity, meteor impacts, shifts in ocean chemistry, or changes in the atmosphere. If you found a strange isotope ratio in a rock layer, your first assumption would be natural causes, and you'd probably be right. But if the anomaly was widespread, if it appeared in multiple locations around the planet, if it coincided with other unusual features, then it might be worth a second look. It wouldn't be proof, but it would be interesting, and interesting is often where discoveries start. Then there are rare elements. Certain elements, platinum, iridium, osmium, are extremely rare in Earth's crust but more common in asteroids and comets. When we find high concentrations of iridium in sediment layers, we interpret it as evidence of meteor impacts. The most famous example is the iridium layer at the boundary between the Cretaceous and Paleogene periods, the line that marks the extinction of the dinosaurs. That layer is found all over the world, and it's strong evidence that a massive asteroid struck Earth 65 million years ago. But what if a similar layer existed, not from a meteor, but from industrial activity? What if a visiting civilization mined asteroids, processed materials in orbit, and some of that material, dust, debris, waste, drifted down into Earth's atmosphere and settled into the sediment? It would look at first glance like a meteor impact. But if you studied it closely, if the isotopes were wrong, if the distribution was different, if there were other anomalies nearby, you might start to wonder. You might start to ask whether the explanation you've been using is really the only one that fits. This is speculative, of course. We have no evidence that this has happened. But the point is that unusual concentrations of rare elements could be technosignatures, and we might already have some in the geological record without realizing it. Because we're not looking for them. We're looking for natural explanations, and we usually find them because natural explanations are almost always correct. But almost isn't always. And if we want to take the possibility of ancient visitation seriously, we have to be willing to look at familiar things in unfamiliar ways. There's also the question of synthetic molecules. Humans have created thousands of compounds that don't exist in nature: plastics, pesticides, pharmaceuticals, refrigerants. Some of these molecules are incredibly stable. They break down slowly, and even when they do, they leave behind fragments that are recognizable as artificial. CFCs, for example, the chemicals that once depleted the ozone layer, persist in the atmosphere for decades. If human civilization ended tomorrow, traces of CFCs would still be detectable thousands of years from now, maybe longer. Would an alien civilization use similar chemicals? Maybe not. Their technology might be completely different. But if they did, if they released synthetic molecules into Earth's environment, those molecules might persist in certain conditions, in ice, in deep sediment, in environments where decomposition is slow. And if we found them, if we recognized them as synthetic, it would be a smoking gun. The problem again is recognition. If a molecule doesn't match anything we know, we might assume it's just a natural compound we haven't catalogued yet. We might file it away and forget about it. Unless we're specifically looking for something artificial, we might never connect the dots. Then there are structural anomalies. Rocks and minerals form in predictable ways, following the laws of physics and chemistry. Crystals grow in specific patterns. Sediment layers settle horizontally. Erosion creates smooth curves, not sharp angles. When we find something that doesn't fit these patterns, something too regular, too symmetrical, too precise, we pay attention. Sometimes it turns out to be a rare but natural formation. Sometimes it's a fossil. And sometimes, very rarely, it's evidence of human activity, a carved stone, a foundation, a tool. Could the same principle apply to alien artifacts? If a structure was built with materials that don't weather the same way natural rock does, if it retained geometric shapes after millions of years, if it was buried in a context that doesn't make sense geologically, it might stand out. But it would have to be found first. And given how much of Earth's surface we've explored in detail, the odds of stumbling across something like this are vanishingly small. We've mapped the continents, but we haven't dug them up. We've surveyed the ocean floor, but we haven't examined it closely. Most of the planet is still, in a meaningful sense, unexplored at the level of detail needed to find something subtle, something small, something strange. So the techno-signatures might be there, isotopes out of place, elements in the wrong concentrations, molecules that shouldn't exist, structures that don't quite fit. But finding them would require knowing what to look for, where to look, and how to distinguish them from the countless natural oddities that already exist in the geological record. It's not impossible, but it's hard, very hard. And it's made harder by the fact that we're not really looking. We're doing other science, studying climate, understanding evolution, mapping resources. The search for ancient alien techno-signatures isn't a priority because, frankly, it's a long shot. But long shots sometimes pay off. And even if they don't, the act of looking changes how we see the world. It makes us more careful, more curious, more willing to question assumptions, and that, in itself, might be worth the effort. Still, there are places on Earth where evidence, if it exists, might be better preserved. Places where time moves more slowly, where the planet's recycling system hasn't ground everything down quite yet. And some of those places are closer than you might think, not in ancient rocks or distant deserts, but in the deep, dark, mostly unexplored waters that cover most of our planet. We think of Earth as a well-explored planet. We have maps, satellites, GPS systems that can pinpoint our location within a few meters. We've climbed the highest mountains, crossed the harshest deserts, and reached both poles. We've sent people to the moon and rovers to Mars, and yet more than 80% of the ocean remains unmapped, unobserved, and largely unknown. We know more about the surface of Mars than we do about the bottom of our own seas. And if you're looking for a place where evidence of ancient visitation might survive, hidden from erosion, protected from tectonic recycling, the deep ocean floor is one of the best candidates. Think about it. The ocean covers about 70% of Earth's surface. Most of it is deep, more than 1,000 meters down, and much of it is far deeper than that. The average depth is around 3,700 meters, more than 2 miles. At those depths, there's no sunlight, no storms, no seasons. The environment is cold, dark, and remarkably stable. Sediment drifts down slowly from the surface, settling in layers millimeter by millimeter, century by century. Objects that sink to the bottom are buried gradually, preserved in the soft mud, protected from the erosion and weathering that destroy everything on land. This doesn't mean the ocean floor is unchanging. It has its own dynamics, its own forms of activity. Underwater volcanoes erupt. Hydrothermal vents spew minerals and superheated water. Tectonic plates shift and grind. And in some places where plates meet, the seafloor is pulled down into the mantle, subducted and recycled. But those processes are localized. Most of the deep ocean floor, especially in the abyssal plains, the vast flat areas that cover much of the ocean basins, is geologically quiet. Things that end up there can stay there for a very long time. Now imagine a spacecraft, or a probe, or some kind of research station, landing not on land but in the ocean, maybe intentionally to study marine life, or maybe by accident, a malfunction, a miscalculation. It sinks to the bottom. Over time, sediment covers it, slowly, carefully, particle by particle. In a few thousand years, it's buried under meters of mud. In a few million years, it's deep beneath the surface, entombed in sediment that's been compacted into rock, but it's still there. The materials have degraded, certainly, the structure has collapsed, but the shape might remain, a faint outline, an anomaly in the layers, and if someone someday were to drill a core through that sediment, they might find it. The problem is that we don't drill many cores in the deep ocean. It's expensive, difficult, and time-consuming. We do it for scientific research, to study climate history, to understand ocean chemistry, to map the structure of the seafloor. But we're selective. We drill where we expect to find something interesting, where the sediment is likely to contain useful data. If there's an anomaly somewhere else, in a random stretch of abyssal plain that looks no different from any other stretch, we might never go near it. And even if we did, even if we drilled a core and found something unusual, would we recognize it? A fragment of metal, heavily corroded, embedded in sediment layers millions of years old. A ceramic shard, its surface pitted and worn. A pattern of minerals that doesn't quite match the surrounding geology. These things might be dismissed as contamination, as natural oddities, as artifacts of the drilling process itself. Without context, without a reason to suspect artificial origin, they'd be catalogued, stored, and forgotten. This is the frustration of looking for something you don't expect to find. The evidence might be there, but unless you're looking for it specifically, unless you know what it means, it slips past. It becomes invisible, not because it's hidden, but because it's unrecognizable. And the deep ocean, with its vastness and its inaccessibility, is the perfect place for things to slip past. There's another layer to this. The ocean isn't just deep, it's also active, biologically. Life thrives there, even in the darkest, coldest depths. Strange creatures, adapted to extreme pressure, to total darkness, to environments we can barely imagine. They feed on the detritus that drifts down from the surface, on chemicals from hydrothermal vents, on each other, and they interact with anything that ends up on the seafloor. Metal objects become encrusted with organisms, organic materials are consumed, even stone can be colonized by bacteria, slowly dissolved or altered by biological processes. So an object on the ocean floor wouldn't remain pristine. It would be transformed, integrated into the ecosystem, covered by life as much as by sediment. Over millions of years, it might become a reef, a structure so overgrown and altered that its original form is completely obscured. If you saw it, you'd see biology, not technology. You'd see nature reclaiming what was once artificial, turning it into something that looks entirely natural. And unless you cut into it, unless you examined it at a microscopic level, you'd never know. This process of biological and geological integration is one of the reasons evidence is so hard to find. It's not just that things degrade, it's that they transform. They become part of the environment, indistinguishable from it. And the ocean, with its richness and its depth, accelerates that transformation. It's a place where the boundary between artificial and natural blurs quickly, where the marks of intelligence fade into the background noise of life and geology. But here's the interesting part. We're just beginning to explore the deep ocean in detail. New technologies, autonomous underwater vehicles, deep-sea submersibles, advanced sonar systems are making it possible to map and study the seafloor in ways we never could before. We're finding shipwrecks, hydrothermal vents, entire ecosystems that were unknown until recently, and every so often we find something we don't immediately understand. A strange formation, an unusual mineral deposit, a pattern that doesn't fit. Most of these mysteries get solved. They turn out to be natural, interesting, but explainable. But not all of them. Some remain ambiguous, filed away as curiosities, waiting for better data or new perspectives. And maybe, just maybe, one of those curiosities is more than it seems. Maybe it's a techno-signature, a trace of something that visited long ago and came to rest in the one place on Earth where it might actually survive. We won't know unless we keep looking, and we won't look unless we're willing to consider the possibility. Not with certainty, not with belief, but with curiosity, with the understanding that the ocean, vast and deep and mostly unseen, might hold answers to questions we've barely begun to ask. But the ocean isn't the only archive that might preserve evidence better than the land. There's another place, closer than we think but harder to explore in some ways. A place with no atmosphere, no water, no life. A place where time moves differently, where objects can sit undisturbed for billions of years. A place we've been to before, but only briefly, and only to a few small patches of its surface. The moon. If you want to hide something for a very long time, or rather, if you want something to survive undisturbed for geological ages, you couldn't ask for a better place than the moon. It has no atmosphere, so there's no wind, no rain, no weathering. It has no oceans, no rivers, no erosion. It has no tectonic activity, no volcanoes reshaping the surface. It's geologically dead, frozen in time. The footprints left by Apollo astronauts in 1969 are still there, as crisp and clear as the day they are made. They'll remain there for millions of years, barring a meteor impact that happens to hit the exact spot where they are. Now imagine something else landing on the moon. Not humans, but visitors from elsewhere, long before we arrived. Maybe they used the moon as an observation post, a place to watch Earth from a distance without being seen. Maybe they left equipment there, sensors or relays or markers. Maybe they visited once briefly and moved on, leaving behind only traces small and subtle, easy to miss. Would we have found them? Probably not. We've only been to a handful of locations on the moon, 6 landing sites during the Apollo missions, plus a few spots touched by robotic landers. That's an absurdly small fraction of the lunar surface. The moon has about 38 million square kilometers of area. We've explored, meaningfully, maybe a few dozen square kilometers. The rest is untouched, unseen except from orbit. And from orbit, even with high-resolution imaging, small objects are nearly impossible to detect. You'd need to know where to look. The moon also has features that are difficult to explore. Lava tubes, for instance, vast underground tunnels formed by ancient volcanic activity. Some of these tubes are enormous, large enough to contain entire cities. They're stable, protected from meteor impacts and radiation, and they remain at a relatively constant temperature. If you were a visiting civilization looking for a place to set up a base, a lava tube would be ideal, hidden, safe, and accessible. And if you left something there, it would stay there, undisturbed, for as long as the moon exists. We haven't explored any lava tubes yet. We've identified them from orbit. We've seen the collapsed sections that reveal their presence, but we haven't sent anything inside. It's on the list of things to do, eventually, when we have the technology and the funding to support more ambitious lunar missions. But for now, those tubes remain unknown territory, and if there's anything inside them, anything left by visitors millions or billions of years ago, it's waiting in the dark, patient and silent. There's also the far side of the moon, the side that never faces Earth. It's not dark. Despite what people sometimes think, it gets just as much sunlight as the near side. But it's hidden from us, shielded from our view and from our radio signals by the bulk of the moon itself. We didn't see it until we sent spacecraft around to the other side, and we didn't land there until very recently, when China's Chang'e 4 mission touched down in 2019. Most of the far side is still unexplored, unmapped at high resolution, and unseen by human eyes except through images sent back by probes. If you wanted to leave something on the moon and keep it hidden from Earth, the far side would be the obvious choice. A base, a marker, an artifact. Something that sits there, waiting. Invisible to anyone on Earth but perfectly preserved in the lunar vacuum. We wouldn't have found it because we weren't looking, and even if we were, we'd have to go there, physically, to see it. Orbital images can only show so much. Small objects, especially if they're designed to blend in, might not show up at all. Then there's the question of intentionality. If a civilization wanted to leave a message for future explorers, for species that might someday develop the technology to reach the moon, where would they put it? Somewhere obvious, maybe near a prominent landmark, the edge of a large crater, a mountain peak, a place where anyone exploring the moon would eventually go, and they'd make it durable, something that could last billions of years without maintenance, stone perhaps, or metal, or something we don't have a name for yet. An object or a structure that stands out just enough to be noticed but doesn't require advanced technology to find. We haven't found anything like that. But again, we've barely looked. The Apollo missions were exploratory, proof of concept, not comprehensive surveys. The astronauts had limited time, limited mobility, and specific scientific objectives. They collected rocks, took photos, ran experiments, and left. They weren't searching for artifacts. They were just trying to understand what the moon was made of and how it formed. Future missions might be different. As we return to the moon, as we establish permanent bases, as we explore more widely and more carefully, we'll see things we didn't see before. We'll map every crater, every boulder, every unusual formation, and maybe, in the process, we'll find something unexpected. Not because it's been hidden intentionally, but because we finally looked in the right place. There's also the possibility of debris. If a spacecraft orbited the moon, refueled there, or used it as a staging area, it might have left behind waste, discarded equipment, or fragments from repairs. These wouldn't be artifacts in the intentional sense, they'd be trash. But trash, if it's durable, can survive just as long as anything else. And on the moon, with no atmosphere to burn things up, no ocean to swallow them, no bacteria to decompose them, trash lasts forever. So somewhere on the moon, maybe in a crater, maybe half buried in regolith, maybe inside a lava tube, there could be a piece of metal, a fragment of ceramic, a shard of something that didn't form naturally, and it would sit there, unremarkable, unnoticed, until someone happened to pick it up and wonder why it looked the way it did, why the composition was strange, why the isotopes didn't match, why it seemed, in some indefinable way, wrong. This is speculation, of course. We have no evidence that anything like this exists. But the Moon is a better archive than Earth for exactly this reason. It doesn't erase, it doesn't recycle, it preserves. And if there's evidence of ancient visitation anywhere in our immediate cosmic neighborhood, the Moon is one of the most likely places to find it. But even if nothing is on the Moon, even if the seafloor holds no secrets, even if the geological record on Earth has been thoroughly scrubbed clean, there's still another kind of trace to consider. Not physical, not material, but biological. Written not in stone or metal, but in the code of life itself. Life on Earth is an archive of its own. Every organism carries within its cells a record of its evolutionary history, written in the language of DNA. Genes are passed down, modified, recombined, shaped by mutation and selection over millions of years. When scientists sequence a genome, they're reading a story of adaptation, survival, and change. And sometimes, buried in that story, there are passages that don't make sense, sequences that seem out of place, relics of events we don't fully understand. Could some of those relics be traces of contact? Not physical contact, but biological intervention, genetic modification, or even accidental contamination? It's a strange question, and a deeply speculative one, but it's worth considering. Because if a visiting civilization studied life on Earth, if they interacted with it in any way, they might have left marks not on the land, but in the living things themselves. Let's start with the most straightforward possibility: contamination. If beings from another world visited Earth, they would bring with them their own biology, or something like it. Microbes, spores, fragments of genetic material. Even if they were careful, even if they sterilized their equipment, absolute decontamination is nearly impossible. We know this from our own space programs. Despite rigorous protocols, spacecraft carry Earth microbes to other worlds. It's a constant concern for planetary protection, the worry that we might accidentally seed other planets with life from here, complicating the search for native life elsewhere. The reverse could happen too. If visitors came to Earth, they might leave behind traces of their own biology, and if those traces were viable, if they could survive in Earth's environment, they might integrate into the ecosystem. Not as whole organisms, but as genetic fragments, hitchhiking inside viruses or bacteria, spreading through horizontal gene transfer. This happens naturally on Earth all the time. Bacteria swap genes. Viruses insert their DNA into host genomes. Evolution isn't just a process of mutation and selection. It's also a process of borrowing, trading, incorporating genetic material from unexpected sources. So if alien genetic material entered Earth's biosphere, it might still be here, hidden inside the genomes of bacteria, archaea, maybe even more complex organisms. The problem is recognizing it. DNA is DNA. The genetic code is universal, or nearly so, across all life on Earth. If alien life used the same code, the same building blocks, their genes might look no different from ours. You could sequence them and never know they came from somewhere else. But what if they didn't use the same code? What if their biology was different enough to stand out but similar enough to function in Earth's environment? That's a narrow window, and maybe an impossible one. But if it exists, if there are sequences in Earth's genomes that don't fit the evolutionary tree, that don't have clear ancestors, that seem to have appeared suddenly without explanation, those might be worth a closer look. Scientists have found sequences like this. They're called orphan genes, genes that exist in one species or one group of species, but have no known relatives elsewhere. Most of the time, these turn out to be genes that evolved quickly, or genes whose ancestors were lost when other species went extinct. But some remain mysterious. They're functional, they code for proteins, but we don't know where they came from. They might be innovations, brand new inventions of evolution, or they might be something else. There's also the so-called junk DNA, the stretches of genetic material that don't code for proteins, that don't seem to do anything. For a long time, scientists thought this DNA was just evolutionary debris, leftovers from ancient viruses or failed genes. But in recent years, we've learned that some of it is functional, involved in regulation, in turning other genes on and off. Still, a lot of it remains unexplained. And hidden in those unexplained regions, there could be sequences that tell a different story. Now, to be clear, there's no evidence that any of this has happened. No one has found alien DNA in Earth's genomes. No one has sequenced a gene and concluded it came from outside our biosphere. The idea is speculative, bordering on science fiction. But it's not completely implausible. If contact happened, if it involved any kind of biological exchange, this is one place where traces might persist. Not in fossils, not in artifacts, but in the living code that's been copied and passed down through billions of generations. There's another angle to consider. Directed panspermia, the idea that life on Earth was seeded intentionally by another civilization. Not that they visited and modified existing life, but that they sent the building blocks of life here in the first place, kick-starting the whole process. This idea was proposed, half seriously, by scientists like Francis Crick, one of the co-discoverers of DNA's structure. He suggested that life might have been sent to Earth deliberately, inside some kind of spacecraft or probe, as a way for an advanced civilization to spread life across the galaxy. It's a romantic idea, but it's also very hard to test. If life was seeded here, how would we know? The early history of life on Earth is murky. We have fossils from about 3.5 billion years ago, simple single-celled organisms that already had sophisticated biochemistry. How they arose is still unclear. Did life start here, in Earth's oceans, through chemistry we're still trying to replicate in the lab? Or did it arrive from somewhere else, carried by comets or asteroids or something more intentional? Panspermia, the idea that life travels between worlds naturally, is taken seriously by some scientists. Microbes are tough. They can survive in space, at least for a while, protected inside rocks ejected from planets by meteor impacts. Mars and Earth exchange material this way, rocks blasted off one world eventually landing on the other. If life existed on Mars billions of years ago, it could have come to Earth, or vice versa. That's natural panspermia, and it's a real possibility. Directed panspermia is different. It requires intention, a civilization deciding to spread life deliberately, maybe as an act of exploration, seeding worlds so that life has a better chance of arising in the galaxy, maybe as a form of legacy, a way to ensure that something survives even if they don't, maybe for reasons we couldn't begin to guess. If this happened, if life on Earth was planted rather than spontaneous, the implications would be profound. But proving it would require finding something in our biology that shouldn't be there, something artificial, designed, a signature that could only come from intelligence. Some people have looked. They've searched for patterns in the genetic code, for hidden messages encoded in the way DNA is structured. So far, nothing conclusive. The genetic code seems optimized for efficiency, for error correction, but that could be the result of evolution, not design. without something clearly artificial, something that couldn't arise naturally, the question remains open but unanswered. And maybe that's the way it should be. Maybe the line between natural and artificial, between evolved and designed, isn't as clear as we think. Maybe life itself is the kind of thing that could arise in many ways, through chemistry, through intention, through processes we haven't imagined yet. And maybe trying to figure out which one applies to us is less important than recognizing that we're here, that we're part of something larger, that our existence connects to the existence of everything else in ways we're only beginning to understand. Still, the possibility lingers. The idea that somewhere in our DNA, in the DNA of bacteria, of plants, of every living thing on Earth, there might be a message, a trace, a sign that we're not alone and never have been. It's a comforting thought, in a way, and a humbling one, because if it's true, then we're not just the product of Earth. We're the product of something older, something that reached across the stars and planted a seed that grew into forests, oceans, cities, and minds that wonder where it all came from. But DNA isn't the only place to look for traces. There are other records, other places where evidence might hide, not on the ground or in cells, but above us, in the space around our planet, in the orbits and empty regions where things can drift for a very long time without being disturbed. Earth isn't alone in space. It's surrounded by a cloud of objects, natural and artificial, that orbit alongside it. Some are close, satellites in low Earth orbit, circling the planet every 90 minutes. Some are farther out, in geostationary orbits, moving in sync with Earth's rotation, so they seem to hover over the same spot. And some are much farther, drifting in high orbits that take weeks or months to complete. Most of these objects are ours, put there in the last 70 years of space exploration. But not all of them are accounted for, and not all of them necessarily came from Earth. Space is big, even the space immediately around our planet, and it's mostly empty. If something small, something quiet, was placed in a stable orbit a long time ago, it might still be there, overlooked, mistaken for space debris, or simply invisible because no one thought to look. Orbital mechanics are predictable. Objects in certain orbits can remain there for millions of years without significant decay, especially if they're far from Earth where atmospheric drag is negligible. So if a visiting civilization wanted to leave a monitoring station, a relay beacon, or even just a marker, a stable orbit would be a reasonable place to put it. We've done surveys. We track most of the larger objects in orbit, anything bigger than about 10 centimeters in low Earth orbit, and larger objects farther out. But the tracking isn't perfect. Things get missed. Things that are small, dark, non-reflective, or in unusual orbits might not show up in surveys designed to track satellites and debris from human launches. And if an object was deliberately designed to be stealthy, to avoid detection, it would be even harder to find. There's also the question of what we'd do if we found something anomalous. An object in orbit that doesn't match any known launch, that has an unusual shape or composition, that seems to predate human spaceflight. Would we investigate? Would we recognize it as potentially alien? Or would we assume it's a piece of old debris, a fragment from an unknown mission, something natural like a captured asteroid? The default assumption would be the simplest explanation, and unless the object did something obviously artificial, like moving or transmitting, it would probably be catalogued and ignored. Then there are the Lagrange points, specific locations in space where the gravitational pull of Earth and the Sun balance in such a way that objects can remain there with minimal energy. There are 5 Lagrange points in the Earth-Sun system, and they're useful for parking spacecraft. We've put satellites there, observatories and science instruments that benefit from the stable environment. But the Lagrange points aren't new. They've existed as long as Earth has, and if anyone wanted to observe Earth over long timescales, a Lagrange point would be an ideal vantage. We've surveyed some of the Lagrange points, but not exhaustively. They're not empty. They accumulate dust, small asteroids, debris. Most of what's there is natural. But could there be something else? Something that doesn't belong? We wouldn't know unless we looked closely, and even then, distinguishing a small artificial object from a natural rock is difficult without up-close examination. So if there's a probe at a Lagrange point, quietly observing, recording, waiting, it might be there still, patient and unseen. There's also the atmosphere itself. If a visiting civilization used propulsion systems, those systems would leave traces: exhaust, particulates, chemical signatures. Most of these would disperse quickly, diluted into the vastness of the atmosphere or washed out by rain. But if the visitation happened during a time when atmospheric chemistry was different, when the planet was less dynamic, the traces might have been preserved in ice cores, in sediment layers, in places where air gets trapped and archived. Scientists study ancient atmospheres this way. They drill cores through polar ice, through glaciers, through sediment at the bottom of lakes. Each layer represents a snapshot of the atmosphere at a particular time. They can measure carbon dioxide, methane, oxygen, trace gases, even dust and pollen. And sometimes they find anomalies, spikes or drops in certain chemicals that don't match known events. Usually these are explained by volcanism, by shifts in ocean circulation, by changes in plant life, but not always. Some anomalies remain unexplained, curiosities in the data that don't fit any model. Could some of those anomalies be technosignatures? A brief spike in rare isotopes, a concentration of synthetic molecules, a shift in atmospheric chemistry that coincided with nothing else happening on Earth. It's possible, but it's also very hard to prove. The atmosphere is complex. It's influenced by so many factors that isolating a single cause is almost impossible. And without corroborating evidence, without something physical to point to, an atmospheric anomaly is just a puzzle, not proof. Still, the idea is compelling. The notion that somewhere in the layers of ice or sediment, there's a chemical fingerprint of a visit that happened so long ago the planet has almost forgotten it. A moment when something from elsewhere passed through, leaving only a whisper in the air, a whisper that got trapped and frozen and buried, waiting for someone to dig deep enough to hear it. And if we expand the search outward, if we look not just at Earth's orbit but at the space around the entire inner solar system, the possibilities multiply. Asteroids that might have been moved or mined, comets with unusual trajectories, small objects in solar orbit that don't fit the patterns of natural debris. Space archaeology is a new field, still in its infancy, but it's growing. As our ability to survey and catalogue objects improves, as our instruments get more sensitive, we might find things we didn't expect. Or we might not. The vastness of space works against us. Even in our own orbital neighbourhood, even in the relatively small volume around Earth, there's so much room to hide. An object the size of a car placed in a high orbit or a distant Lagrange point would be nearly impossible to detect unless it wanted to be found. And if it's been there for millions of years, if it's degraded, if it's covered in dust and micrometeorite impacts, it might look no different from any other piece of rock drifting through the void. So the search continues, slowly, patiently, without expectation but with openness. Because even if we find nothing, Even if the skies around Earth are empty of everything but our own debris and natural objects, the act of looking teaches us something. It teaches us to see our planet in context, as one small world in a galaxy full of worlds, as a place that might have been visited, might be visited still, or might remain quietly alone, waiting for the day we venture out and become the visitors ourselves. But before we turn that lens outward, before we imagine ourselves as the explorers, there's another question to consider. One that's less about evidence and more about psychology, about why a civilization might choose to stay hidden even if they were here, about the ethics of contact and the reasons for silence. If Earth has been visited, if civilizations from across the galaxy have stopped here, observed, studied, perhaps even lingered, then why didn't they make contact? Why didn't they land in a visible place, announce themselves, leave a message we couldn't miss? It's easy to assume that any advanced civilization would want to communicate, to share knowledge, to make their presence known. But that assumption says more about us than it does about them, because contact is a choice, and silence is a choice too. And there are many reasons, good reasons, why a visiting civilization might decide to watch without being seen. The most common explanation is called the zoo hypothesis. The idea is simple. Earth is being observed, but from a distance the way we might observe animals in a nature preserve. We don't interfere. We don't make ourselves known. We let the animals live according to their own patterns, their own instincts, their own developmental path. The goal isn't to control or to guide, it's to observe, to learn, to see what happens when life is left to unfold naturally. If an advanced civilization approached Earth with this mindset, they might establish strict protocols about contact, rules designed to prevent interference, contamination, or disruption. This idea resonates with something we already understand from our own ethics. We have rules about contacting isolated human cultures, groups that have had little or no interaction with the outside world. The general consensus is to leave them alone, to let them develop on their own terms, to avoid introducing diseases, technologies, or ideas that might destabilize or harm them. It's not about superiority or control, it's about respect, about recognizing that contact is not always beneficial, that sometimes the best thing you can do is nothing. Now scale that up. Imagine a civilization millions of years old, with experience observing thousands of worlds, watching life arise and evolve and sometimes become intelligent. They would have seen what happens when younger civilizations encounter older ones, the power imbalance, the cultural shock, the ways that contact can derail development or create dependency. They might have decided, based on long experience, that non-interference is the kindest policy, that emerging civilizations need space to grow, to make their own mistakes, to find their own path, and so they watch, but they don't touch. This doesn't mean they're indifferent. It means they care enough to be careful, to let us figure things out on our own, to let us reach a certain level of maturity before revealing themselves, if they reveal themselves at all. It's a version of what science fiction has called the prime directive, the idea that advanced species should not interfere with the natural development of less advanced ones. It's speculative, of course. We have no way of knowing if such ethics are universal, or even common. But it's not hard to imagine, and if it's true, it would explain the silence. There's also the possibility of fear, not fear of us exactly, but fear of what contact might do. Fear of contamination, biological or cultural. If a visiting civilization carried microbes we had no immunity to, or if we carried microbes they had no immunity to, contact could be catastrophic for one side or both. This is a real concern even within our own species. When Europeans made contact with the Americas, diseases spread that decimated populations who had no prior exposure. The same could happen on a cosmic scale. An alien visitor might avoid direct contact simply to protect both themselves and us from biological exchange. Cultural contamination is subtler, but potentially just as serious. Ideas are contagious. Technologies, philosophies, religions, social structures. If a highly advanced civilization shared even a small amount of their knowledge with us, it could overwhelm our own development. We might stop inventing, stop questioning, stop growing, because someone else already has the answers. We might become dependent, imitative, shaped by their influence in ways that erase our uniqueness. And if they value diversity, if they see each civilization as a distinct and valuable expression of what life can become, they might choose silence to preserve that diversity. Then there's the possibility that contact happened and we forgot. Not recently, but long ago, when humans were still hunter-gatherers, still shaping language and culture, still trying to understand the world. A visit during that time might have been witnessed, remembered, passed down through stories, but not in the way we'd recognize as factual. It would become myth, legend, a story about gods descending from the sky, about beings with great power, about events that shaped the world, and over thousands of years the details would shift, the meaning would change, until what was once a real encounter became something else entirely, something symbolic, something sacred, something divorced from its original context. Many cultures have stories like this, stories of sky beings, of visitors who came from above, who taught certain things and then left. Stories of great floods, of cataclysms, of moments when the world changed and the old ways ended. Some of these might be memories of real events, astronomical phenomena, comets, eclipses, supernovas. But some might be something else. The challenge is that oral traditions change over time. They're not recordings. They're living stories, reshaped by each generation, adapted to new contexts, new meanings. So even if contact happened, even if it was remembered, we might not recognize it for what it was. This brings up an uncomfortable question. If contact happened and was forgotten, if it's been encoded in myths and legends but not in a way we can verify, does it still count as evidence? And if it doesn't, what does that say about our standards for proof? Are we too rigid, too insistent on material evidence when the real traces might be cultural, embedded in stories and symbols that have persisted for thousands of years? There's no easy answer. Scientists are rightly cautious about treating myths as factual accounts. Myths are valuable. They tell us about human psychology, about how people make sense of the unknown, but they're not reliable records of actual events. At the same time, dismissing them entirely feels narrow, like refusing to consider a whole category of evidence simply because it doesn't fit our methods. The truth, as usual, is probably somewhere in the middle. Some myths might contain kernels of real events, others are purely imaginative, and without independent corroboration we can't tell which is which. There's also the question of whether contact would even be recognizable. We imagine aliens as dramatically different from us, but what if they're not? What if they're subtle, quiet, able to blend in or observe without being noticed? What if they don't use technology we'd recognize as technology? What if they operate on timescales so long, or at scales so small, that we simply don't perceive them? Contact might be happening right now, in ways we're not equipped to see. This sounds like paranoia, or like the kind of thinking that leads to conspiracy theories. But it's worth considering, if only as a thought experiment, because our ability to detect and interpret phenomena is limited by our senses, our instruments, and our expectations. We see what we're looking for, we notice what stands out, and if something is designed not to stand out, or if it exists in a domain we haven't learned to explore, we could miss it entirely. So maybe the question isn't why they're hiding. Maybe the question is why we assume we'd notice them in the first place. Maybe silence isn't a choice they're making. Maybe it's a limitation we're experiencing. And maybe the first step toward contact, if contact is possible, is expanding our awareness, learning to see in new ways, to listen for signals we've been ignoring, to recognize patterns we've been dismissing as noise. But all of this assumes a single perspective, a single way of thinking about contact. What if different civilizations have different approaches? What if some hide, some announce themselves, some leave markers, and some simply pass through without lingering? What if Earth has been visited by many, each with their own reasons, their own ethics, their own sense of what's appropriate? Then the picture becomes even more complex, not a single story, but many stories, overlapping, contradictory, impossible to disentangle. And maybe that's closer to the truth. Maybe the galaxy is full of travelers, each with their own motivations, their own histories, their own reasons for stopping or moving on. And maybe Earth, over its long history, has been touched by some of them, in ways we'll never fully understand, not because the evidence is hidden, but because the question is bigger than we thought. Because it's not just about whether they visited, it's about why, how, when, and what it meant to them. And those are questions we might never answer, even if we find proof that they were here. Still, there's value in asking. Because the act of wondering, of imagining, of considering possibilities beyond our immediate experience changes us. It makes us more curious, more humble, more aware of how much we don't know. And that awareness is its own kind of contact, a reaching out not to them, but to the vastness they represent, to the unknown they embody, to the possibility that we're part of something larger, something stranger, something more beautiful than we've been able to see. And some of the stories we carry, the stories told by people who have lived close to the land, close to the sky, for thousands of years, might offer perspectives we've overlooked, not as proof, but as invitations to think differently. There's a richness in the stories that have been passed down through generations, stories told by indigenous peoples around the world, stories about the sky, about visitors, about beings who came from above and changed things. These aren't monolithic narratives, they're diverse, specific, tied to particular places and cultures, and they deserve to be approached with respect, not as evidence to be extracted and repurposed, but as perspectives that offer different ways of understanding the relationship between Earth and the cosmos. Many indigenous cultures have traditions of star people, sky beings, ancestors or teachers who came from the heavens. In some stories, these beings brought knowledge, taught certain skills, or helped shape the world. In others, they were observers, watchers, or messengers. The details vary widely, but the pattern is there, a connection between Earth and the sky, between human experience and something larger, something beyond. Now, it's important to be careful here. It's easy to fall into the trap of treating these stories as literal accounts of alien contact, of taking complex cultural narratives and flattening them into simple proof of visitation. That's reductive, and it's disrespectful. These stories aren't artifacts to be mined. They're living parts of cultures that continue to exist, to evolve, to hold meaning for the people who tell them. And the meanings are often layered, spiritual, symbolic, not easily translated into the language of science or the framework of extraterrestrial contact. But that doesn't mean the stories have nothing to offer. They reflect deep observation of the natural world, of the sky, of patterns and cycles that unfold over lifetimes and generations. Indigenous astronomers tracked stars, planets, comets and eclipses with precision that rivals or exceeds what was happening in other parts of the world at the same time. They built structures aligned to celestial events. They developed calendars, navigation systems, cosmologies that integrated the sky with the land, with the seasons, with the stories of their people. So when these traditions speak of sky beings, of visitors, of connections to the stars, they're not speaking carelessly. They're speaking from a place of careful attention, of long memory, of knowledge accumulated over thousands of years. And while we can't take these stories as literal descriptions of alien encounters, we also shouldn't dismiss them as mere fantasy. They might be encoding something real, something observed, something that doesn't fit neatly into the categories we're used to. Maybe they saw meteors and interpreted them as visitors. Maybe they saw auroras, comets, or rare astronomical phenomena and wove them into narratives about beings from above. Maybe they witnessed things we'd now classify as natural, but were, to them, experiences of contact, of connection, of communication with the cosmos. Or maybe, just maybe, they saw something else. Something we'd call anomalous. Something that doesn't fit the natural explanations but also doesn't offer clear proof of anything artificial. The challenge is that we can't go back. We can't interview the people who first told these stories. We can't ask them what they saw, what they meant, what they were trying to preserve. All we have are the stories themselves, passed down, reshaped, reinterpreted, and still alive. And the best we can do is listen, not with the goal of extracting answers, but with the humility to recognize that there are ways of knowing, ways of relating to the universe, that don't fit the framework of Western science but are valuable nonetheless. There's also a lesson here about memory. Indigenous oral traditions have preserved knowledge for thousands of years, longer than written records in many cases. They've remembered migrations, catastrophes, changes in landscape and climate. They've remembered the locations of resources, the behaviors of animals, the patterns of weather. And they've done it without writing, without databases, without the tools we think of as necessary for long-term memory. So if contact happened, if something significant occurred in the deep past, it's not impossible that memory of it could have been preserved this way. Not as a detailed factual account, but as a story, a pattern, a sense that something important happened. And maybe, if we were willing to listen more carefully, to engage with these traditions on their own terms rather than trying to force them into ours, we'd learn something. Not proof, but perspective. Not certainty, but context. It's also worth recognizing that the Western scientific tradition, as powerful and successful as it is, doesn't have a monopoly on truth. It's one way of knowing, one method of investigation, shaped by particular assumptions and particular goals. Other cultures have developed other ways of knowing, other methods, other goals. And sometimes those methods capture things science misses, not because science is wrong, but because it's looking in a different direction. This doesn't mean we should abandon science or accept claims without evidence. It means we should be open to the possibility that evidence comes in many forms and that understanding requires more than one perspective. The stories of sky people might not prove alien visitation, but they remind us that the relationship between humans and the cosmos is old, deep, and full of wonder. That people have been looking up, asking questions, and trying to make sense of the lights in the sky for as long as there have been people, and that their answers, their stories, their ways of holding those questions are part of the human inheritance, part of the conversation we're still having. So we hold these stories gently, with respect and curiosity, without demanding they fit our expectations. We let them be what they are, rich and complex and meaningful, and we recognize that maybe, just maybe, they're pointing towards something we haven't fully understood yet. Not because they're evidence, but because they're invitations. Invitations to think differently, to imagine more broadly, to consider that the universe might be stranger and more connected than we've been taught to believe. And as we think about what it would take for someone to visit Earth, as we consider the immense distances and the staggering energy required, we're reminded that the question isn't just whether it's possible. It's whether anyone would bother, whether the effort, the cost, the risk would be worth it. And that brings us to one of the hardest parts of this entire question, the problem of actually getting here. Space is big. That's obvious. But it's worth saying again because the size of space is one of the most fundamental obstacles to interstellar travel. The distances between stars are so vast that they're almost impossible to comprehend. The nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away. That means light, travelling at 300,000 kilometers per second, takes more than 4 years to get there. And light is the fastest thing in the universe. Nothing with mass can go that fast. So any spacecraft, any probe, any living being trying to cross that distance would take longer. Much longer. Our fastest spacecraft, Voyager 1, launched in 1977, is currently moving at about 17 kilometers per second relative to the Sun. That's fast by human standards, fast enough to cross the United States in about 4 minutes. But at that speed, it would take more than 70,000 years to reach Proxima Centauri. And Proxima Centauri is the closest star. Most stars are much farther away. The galaxy is 100,000 light-years across. If you wanted to travel from one side to the other at Voyager speed, it would take billions of years, longer than the current age of the universe. So clearly, if anyone is traveling between stars, they're not doing it at the speeds we're currently capable of. They've solved the energy problem in ways we haven't, and that's a massive problem. Moving something, anything, at a significant fraction of the speed of light requires enormous amounts of energy. The faster you want to go, the more energy you need, and the relationship isn't linear, it's exponential. By the time you're approaching even 10% of light speed, the energy requirements are staggering, far beyond anything we can currently produce. Let's put some numbers to it. Imagine you want to send a small spacecraft, say 1 ton, to Proxima Centauri at 10% of light speed. That trip would take about 40 years, fast enough to be useful, slow enough to be theoretically possible. To accelerate that spacecraft to that speed, you'd need energy equivalent to several times the world's current annual energy consumption. And that's just to get it moving. You'd also need energy to slow it down when you arrive, unless you're just doing a flyby. And if you want to carry people, you need a much larger spacecraft with life support, radiation shielding, supplies. The energy requirements multiply quickly. There are theoretical solutions. Nuclear fusion, where you fuse hydrogen atoms into helium and extract the energy released, could provide much more power than chemical rockets. Antimatter, where matter and antimatter annihilate each other and convert their mass directly into energy, could be even more efficient. But both of these technologies are far beyond what we can currently do. We can barely sustain fusion reactions in a lab, let alone build a fusion-powered starship. And antimatter is so difficult to produce and store that we measure it in nanograms, not kilograms or tons. Then there are more exotic ideas, solar sails, which use the pressure of sunlight to accelerate, could eventually reach high speeds without carrying fuel. but they're slow to get going and they only work near a star. Laser sails, where powerful lasers push a spacecraft from behind, could accelerate much faster, but they require enormous infrastructure and perfect targeting. Warp drives, hypothetical engines that bend space-time itself, allowing a ship to move faster than light without technically breaking the laws of physics. These are fun to think about, but they require forms of matter and energy that might not even exist. Exotic matter with negative mass, or energies equivalent to the output of entire stars. So the problem is real. Getting from one star to another is hard. It requires either enormous amounts of energy or very long periods of time, or both. And any civilization that's managed to do it has overcome challenges we can barely conceptualize. But here's the thing. Hard doesn't mean impossible. It just means difficult. And given enough time, enough motivation, enough technological development, difficult problems get solved. Earth has only been a technological civilization for a few centuries. We've been spacefaring for less than a century. If we survive, if we keep developing, if we solve our immediate problems and turn our attention outward, who knows what we'll be capable of in 1,000 years, in 10,000, in 1,000,000? The gap between us and a civilization that's been around for millions of years is almost unimaginable. They would have had time to solve problems we haven't even thought of yet, to develop technologies that seem like magic to us, to make interstellar travel routine, efficient, safe. And if they did, if they cracked the energy problem and found a way to move between stars at reasonable speeds, then the galaxy would be open to them. Not all at once, not quickly, but eventually. They could send ships to nearby stars, establish outposts, explore, and then move farther. Generation ships where multiple generations live and die during the journey could carry populations across the void. Suspended animation or some form of stasis could let travelers sleep through the decades or centuries. Robotic probes, self-replicating machines that build copies of themselves when they arrive, could explore without needing life support. There are options, not easy ones, but options. And if a civilization was patient, if they thought in terms of millennia rather than years, they could spread slowly across the galaxy, visiting worlds, observing, learning, leaving traces or not, depending on their goals and ethics. The question then becomes, how often would they visit? If interstellar travel is difficult and expensive, even for an advanced civilization, they'd probably be selective. They wouldn't visit every world. They'd focus on interesting ones, places with life, with complex ecosystems, with potential for intelligence. Earth would qualify. It's been a living planet for billions of years, and for much of that time it's been visibly alive, with oxygen in the atmosphere, a clear biosignature detectable from space. Any civilization scanning nearby stars for habitable worlds would notice Earth, and if they had the means, they'd probably come take a look. But how many times? Once? 12 times? Hundreds? If different civilizations arose at different times in different parts of the galaxy, each might have explored independently. Each might have visited Earth on their own schedule. The first visitors might have come billions of years ago when Earth was young and covered in shallow seas. The most recent might have come yesterday, or might be on their way now. There's no reason to assume visitation would be a single event. It could be an ongoing process, slow and scattered, with long gaps between visits, but persistent over deep time, and each visit might be brief, a few orbits to gather data, a landing to collect samples, a temporary station to monitor the planet for a while, then departure, moving on to the next world, the next system, the next question, They wouldn't stay because staying isn't necessary. They'd learn what they came to learn, record it, and leave. And Earth would continue, shaped by its own processes, its own life, with only the faintest traces, if any, that someone paused to watch. So the energy problem doesn't rule out visitation. It just makes it less frequent, more deliberate. It means that anyone who came here made a choice, invested resources, committed to the journey. And that, in a way, makes the possibility more meaningful, because it means Earth mattered. It was interesting enough, valuable enough, worth the effort. Whether we ever find proof of that or not, the idea itself is a kind of connection, a reminder that we're part of a larger cosmos, one where distances are vast but not insurmountable, where curiosity can cross the void, where the desire to see, to know, to explore might be universal. But even if they solved the energy problem, even if they could travel here, why would they keep coming back? What would bring them to Earth more than once? That's a question worth exploring, because it speaks to motivation, to what drives intelligence, to what makes a place worth visiting again and again. Earth changes. That's one of the most important things about it, and one of the things that might make it worth revisiting. 1 billion years ago, Earth was different. The continents were in different places. The atmosphere had less oxygen. Life was simpler, mostly single-celled. If a civilization visited then, they would have seen a planet in an early stage of development, interesting but unremarkable. If they came back a few 100 million years later, they'd find something new. Multicellular life, complex organisms, ecosystems that didn't exist before, and if they kept coming back periodically over deep time, they'd witness one of the most extraordinary processes in the universe, the unfolding of evolution. That's a reason to return, not to interfere, but to observe, to see how life develops, how it adapts, how it fills every niche and creates new forms of complexity. Earth is a laboratory, not in the sense of something controlled, but in the sense of something natural that offers lessons. Every living planet tells a story, and Earth's story is still being written. A civilization interested in biology, in evolution, in the patterns that emerge when chemistry becomes life and life becomes intelligence, would have good reason to check in periodically, to see what's changed, to compare this visit with the last, to build a longitudinal study spanning millions of years. Scientists do this on Earth. They return to the same sites, year after year, decade after decade, measuring changes, tracking populations, observing ecosystems over time. Long-term ecological research sites exist all over the world, places where data has been collected continuously for decades. Some studies have run for over a century. The goal is to see patterns that only emerge over long timescales, to understand processes that are invisible if you only look once. An advanced civilization might do the same thing, but on a planetary scale, returning to Earth every million years or so to see how things have progressed. And Earth has been through a lot. Mass extinctions, climate shifts, the rise and fall of dominant species. Each of these events reshaped the planet, changed the trajectory of life, opened new possibilities. If you were studying Earth, you'd want to see these transitions. You'd want data from before and after. You'd want to understand how life rebounds, how ecosystems reassemble, how intelligence emerges from the ruins of what came before. So visitation wouldn't be random. It would be strategic, time to catch important moments or spaced evenly to build a consistent record. There's also the possibility that Earth serves a practical function. Not as a resource to be exploited, the galaxy is full of raw materials, but as a waypoint, a place to rest, refuel, or repair. If interstellar travel is difficult, If it requires careful planning and long journeys, then having known safe harbours would be valuable. Places where you can stop, where conditions are stable, where you can resupply water, refuel if your propulsion uses hydrogen or other elements abundant here, or simply pause before continuing. Earth is well positioned for this. It's in a relatively calm part of the galaxy, far from the dense, radiation-heavy core, but not so far out that it's isolated. It orbits a stable, long-lived star. It has a strong magnetic field that deflects harmful radiation. It's safe, predictable, easy to navigate to. If you're crossing this part of the galaxy and you need a place to stop, Earth makes sense. Not as a destination, but as a rest stop. A place you visit repeatedly, not because it's special, but because it's convenient. And if multiple civilizations travel through this region, if there's something like a network of travelers, each following their own routes, checking the same useful locations, then Earth might be a known spot. A place marked on galactic maps, if such things exist. A place where you can expect to find what you need, where you know the conditions, where you've been before. Over millions of years, dozens of civilizations might pass through, each stopping briefly, each adding to a slow accumulation of visits that leaves almost no trace. There's another darker possibility: refuge. A civilization fleeing disaster might come to Earth seeking safety, shelter, a place to hide or recover. They might stay longer than others, might leave more behind, might even try to settle. But if they're desperate, if their numbers are small, if they're damaged or sick or simply unlucky, they might not survive. They might die out, their presence forgotten, their artifacts degraded, their story untold. And Earth would move on, unaware that it briefly hosted refugees from a catastrophe light years away. This idea has a certain sadness to it. The notion that someone came here hoping for a new beginning and didn't make it, that they left traces we might someday find, traces that tell a story of loss, of struggle, of a journey that ended quietly on a world that wasn't theirs. It's speculative, almost certainly unprovable, but it's a reminder that not all stories have happy endings, that the galaxy might be full of quiet tragedies as well as triumphs. Then there's the possibility of intentional markers. If Earth is a place worth visiting, it might also be a place worth marking for others. A civilization might leave a beacon, a signal, a monument designed to say we were here. Not for us necessarily, but for whoever comes next. For other explorers, other travelers, other intelligences that might arise on Earth itself or visit from elsewhere. A kind of guest book, a record of passage, a way of participating in something larger than themselves. These markers would need to be durable, designed to last millions of years. They might be placed on the Moon, in orbit, or in some geologically stable location on Earth. They might use materials that don't degrade, structures that don't erode, symbols that transcend language. And they might be subtle, not obvious from a distance, but recognizable up close. A way of saying we see you without shouting. We haven't found anything like this. But again, we've barely looked. And if a marker was designed to be found only by a civilization advanced enough to explore space, only by beings capable of reaching the Moon or mapping the seafloor, then it would still be waiting. Patient, silent, ready to be discovered when we're ready to see it. All of these motivations, scientific curiosity, practical need, refuge, marking, point to the same conclusion. That visitation, if it happened, wouldn't be a single event with a single reason. It would be many events, many reasons, a tapestry of encounters spread across deep time, each visit driven by its own circumstances, its own goals, its own sense of what Earth represents. And maybe the question isn't whether they visited. Maybe the question is what we'd do if we knew they had. Would it change us? Would it comfort us, knowing we're not alone, that others have been here, that the universe is full of minds and stories? Or would it unsettle us, knowing we've been watched, studied, perhaps judged, without ever realizing it? These are human questions, emotional questions, and they don't have clear answers, but they're worth sitting with because they touch something deep in us, the desire for connection, for meaning, for a place in the larger story of the cosmos. And as we think about all of this, as we consider the possibilities and the probabilities, there's something else happening now, something closer to home, something that adds new dimension to the entire question. We're starting to see things we can't explain. For decades, reports of unidentified flying objects, UFOs, were treated as fringe material, the domain of conspiracy theorists, enthusiasts, and people whose credibility was questionable. Mainstream science stayed away. The subject was tainted, associated with hoaxes and wild speculation, and anyone who took it seriously risked their reputation. But something has shifted in recent years. The conversation has changed. Not because the evidence suddenly became overwhelming, but because the approach became more serious, more rigorous, more willing to investigate without jumping to conclusions. In 2020, the United States military officially released videos captured by Navy pilots. Videos showing objects moving in ways that seem to defy conventional physics. Fast acceleration, sudden direction changes, no visible means of propulsion. The Pentagon confirmed that the videos were real, that the objects were unidentified, and that they didn't know what they were. They stopped calling them UFOs and started calling them UAPs, unidentified aerial phenomena, a term that sounds more clinical, less loaded with cultural baggage. And they acknowledge that these phenomena are worth studying, not because they're necessarily alien, but because they're unknown, and unknown things, especially things observed in restricted airspace near military assets, deserve attention. This was a significant moment, not proof of anything extraterrestrial, but an admission that something is happening that we don't fully understand. That pilots, trained observers with advanced instruments, are seeing things that don't match known aircraft, known drones, known natural phenomena. That the data is real, the sightings are real, and the questions are legitimate. It opened the door, slightly, for serious scientific investigation of something that had been dismissed for too long. Since then, more reports have emerged, not just from military pilots, but from commercial pilots, air traffic controllers, radar operators, sightings of objects that move too fast, that stop and start without transition, that seem to ignore aerodynamics and inertia. Some are probably misidentifications, tricks of light, reflections, ordinary objects seen under unusual conditions. Some are probably drones, either ours or someone else's, testing new technologies. But some, a small percentage, remain genuinely unexplained, and those are the ones worth paying attention to. The key word here is unexplained, not alien, not extraterrestrial, just unexplained. Because there's a huge gap between we don't know what this is and we know this is alien. That gap is filled with other possibilities. Advanced human technology we're not aware of, natural atmospheric phenomena we haven't catalogued, sensor errors or glitches, psychological effects, the way our brains fill in details or misinterpret ambiguous stimuli. Any of these could explain some or all of the sightings, and until we rule them out, we can't make bigger claims. But here's the thing. Ruling them out requires investigation. It requires taking the reports seriously, collecting data, analysing it carefully, and being willing to say we don't know when we don't know. And for a long time, we weren't doing that. We were dismissing, ignoring, or ridiculing. Now finally we're starting to look, not with credulity, but with curiosity, and that's a step forward. There are also civilian efforts, organisations that collect sighting reports, analyse video and photographic evidence, try to separate signal from noise. Some of this work is careful and methodical, some is less rigorous, coloured by belief or bias. But the existence of these efforts, the fact that people are paying attention, is itself significant. Because phenomena that are ignored don't get explained. They just accumulate in the background, unexamined, until someone decides they're worth the effort. So what are these UAPs? The honest answer is we don't know. Some might be cutting-edge technology, developed in secret by governments or private companies, hypersonic drones, experimental propulsion systems, things that are advanced but still human-made. Some might be optical illusions, artifacts of the way cameras and sensors capture fast-moving objects. Some might be atmospheric effects, ball lightning, plasma phenomena, things that occur naturally but rarely. And some, a very small sum, might be something else. The possibility that they're extraterrestrial has to be on the table, not as the first explanation, not as the default, but as one option among many. Because if Earth has been visited in the past, if civilizations from elsewhere have come here before, why would they have stopped? Why wouldn't they still be observing, still checking in, still passing through? If visitation is an ongoing process rather than a historical event, then some of what we're seeing now might be connected to that. Not definitive proof, but perhaps a continuation of something that's been happening for a very long time. This doesn't mean every UAP is alien. It doesn't even mean most are. It just means we shouldn't rule out the possibility without evidence. And right now, we don't have enough evidence either way. We have sightings, we have data, we have questions. What we don't have are answers. And that's frustrating, but it's also honest, because the universe doesn't owe us clarity. It just is, and we have to work to understand it. The challenge is that UAPs, whatever they are, don't behave in ways that make them easy to study. They're transient, unpredictable, often appearing for only a few seconds or minutes before disappearing. They don't land and wait for scientists to arrive. They don't hold still for analysis, and most of the time, the only data we have is from sensors that weren't designed to track anomalous objects, sensors optimized for aircraft or weather, not for things that move in unexpected ways. So the data is incomplete, ambiguous, open to multiple interpretations. And that's where the debate lives, in the gaps between what we can measure and what we can conclude. Some people see the data and think alien. Some see it and think classified technology. Some see it and think error. And without better data, without more systematic observation, without instruments specifically designed to study these phenomena, we're stuck in speculation. But speculation isn't useless. It drives curiosity, it motivates investigation, and it keeps the question alive, even when answers are elusive. Because the worst thing we could do is decide without sufficient evidence that we already know what these things are or aren't. The worst thing we could do is close the door on possibility simply because it feels uncomfortable or implausible. So we watch, we collect, we analyze, we debate, and we stay open. Not open in the sense of believing everything, but open in the sense of allowing the universe to surprise us. Because it has before. Every major discovery in science has been a surprise, something that didn't fit the old models, something that required us to expand our thinking, and maybe UAPs are the next surprise, or maybe they're a distraction, a collection of mundane phenomena that only seem mysterious because we haven't studied them carefully yet. Either way, the process is the same: observation, investigation, rigor, honesty, and patience. Because answers, real answers, take time. They don't come from a single video or a single sighting. They come from patterns, from accumulation, from the slow work of eliminating possibilities until what's left is something solid, something we can test, something we can understand. And while we do that work, while we try to figure out what's happening in our skies right now, we can also step back and ask a broader question. A question that's not about proof or evidence, but about feeling, about what it means to wonder, to reach, to hope for connection, even when the universe seems vast and silent. There's something deeply human about wanting not to be alone. It's there in our myths, our religions, our stories, the idea that we're part of something larger, that we're seen, that we matter. We build communities because isolation is hard. We reach out to others because connection gives meaning. And when we look at the night sky, when we see the vastness of space and the billions of stars and the endless dark between them, we feel that same need. The need to know that someone else is out there, that we're not the only ones asking questions, wondering, reaching across the void. The Fermi paradox feels lonely. It asks where everyone is, and the silence it points to feels heavy, like an absence, like a missing piece. If the universe is full of potential, full of stars and planets and opportunities for life, then why does it feel so empty? Why haven't we heard anything? Why haven't we seen anything? Why are we, as far as we know, alone? But maybe the silence isn't as complete as it seems. Maybe we're just not listening in the right way, or at the right time, or in the right places. Maybe the galaxy is full of voices, but they're speaking languages we don't understand, using frequencies we haven't tuned to, operating on timescales that don't match ours. Or maybe the silence is intentional, a choice made by others to let us grow without interference, to give us space to figure things out on our own. The idea that Earth might have been visited, that civilizations from elsewhere have been here, offers a kind of comfort. It says we're not alone, or at least we weren't. It says someone noticed us, cared enough to come, saw something worth observing. It connects us to the larger story of the galaxy, makes us participants rather than isolated observers, and that feels good. It eases the loneliness, but it's also unsettling. Because if they visited and left, if they saw us and moved on, it raises questions about why. Were we interesting enough? Were we worth staying for? Or were we just another stop, another data point, another world among many? And if they're still watching, if they're here now in some form we don't recognize, what do they think of us? Are we meeting their expectations? Are we disappointing them? Are we even on their radar? Or have we become background noise, something they check on occasionally but don't really care about? These are emotional questions, not scientific ones. They come from a place of insecurity, of wanting validation, of needing to know that our existence matters to someone other than ourselves. And they're hard to sit with, because they don't have answers. They just reflect back our own hopes and fears, our need for meaning in a universe that doesn't seem to offer it freely. But maybe that's okay. Maybe the loneliness, the uncertainty, the not knowing is part of what it means to be conscious, to be aware, to be a small spark of awareness in a vast and mostly dark cosmos. Maybe the question is more important than the answer. because the question keeps us looking, keeps us wondering, keeps us connected to the possibility that there's more out there than we've seen. And wanting connection isn't weakness. It's not naive or foolish. It's deeply, fundamentally human. We're social creatures. We evolved in groups, depending on each other for survival, for comfort, for meaning. Isolation, even when it's vast and cosmic, hurts. It feels wrong. So we reach out through our telescopes, through our radio signals, through our imaginations. We send messages into space, hoping someone will hear. We search for biosignatures on distant planets, hoping to find life. We look at UAPs and wonder if maybe, just maybe, someone is looking back. This longing shapes how we approach the question of visitation. We want it to be true, not because we have evidence, but because it would mean we're not alone, that we're part of a community, even if that community is scattered across light years and operates on timescales we can barely grasp. And that want, that hope, can make us see patterns that aren't there, can make us interpret ambiguous data in ways that fit our desires rather than the facts. So we have to be careful. We have to balance hope with rigor, longing with honesty. We have to be willing to accept that the universe might not give us what we want, that the silence might be real, that we might be, for now at least, genuinely alone. Not because the universe is empty, but because the distances are too great, the timescales too long, the chances of overlap too small. But even if we are alone, even if no one has visited, even if the galaxy is full of life but none of it has reached us yet, that's not a reason to despair. Because we're here, we exist, we're conscious, curious, capable of asking these questions, and that, in itself, is extraordinary. We're the universe looking at itself, wondering about itself, trying to understand itself, and whether there are others doing the same thing elsewhere, or whether we're the first, the only, the strange exception, doesn't change the fact that we matter, that our questions matter, that our search for connection, for meaning, for understanding, is valuable in its own right. The loneliness isn't the end of the story, it's the beginning. It's what drives us to look, to reach, to imagine, and maybe someday we'll find what we're looking for. Or maybe we won't. Maybe we'll just keep searching, generation after generation, building better instruments, asking better questions, expanding the circle of what we know and what we wonder about. And maybe that's enough. Maybe the search itself is the connection we've been looking for all along. Because here's the thing, we're not passive in this story. We're not just waiting for someone else to show up and tell us we're not alone. We're active. We're becoming the explorers, the travelers, the ones who might someday visit other worlds. And when we do, when we land on an exoplanet or send a probe to another star system, we'll be the ones deciding whether to make contact, whether to leave traces, whether to interfere or observe. We'll be the ones asking the questions we've been asking about others, and maybe, in that moment, we'll understand something we couldn't before, about why the galaxy might be quieter than we expected, about what it means to be careful, respectful, patient, about the ethics of contact and the value of silence. There's a mirror to this entire question, one that flips the perspective and asks us to imagine ourselves not as the observed, but as the observers. Not as the ones wondering if we've been visited, but as the ones doing the visiting. Because if we survive, if we keep growing and learning and building, if we solve the problems that threaten us now, climate change, resource depletion, conflict, then eventually we'll reach a point where we can travel to other stars. We'll become the civilization that explores, that studies distant worlds, that faces the same questions we've been asking about others. What will we do when we find a planet with life? When we detect biosignatures in the atmosphere of a world dozens of light years away? When we send a probe and confirm that there are oceans, continents, ecosystems? Will we land? Will we take samples? Will we set up observation posts and study the planet over decades or centuries? And if we do, what traces will we leave behind? These aren't hypothetical questions anymore. We're already starting to search for habitable exoplanets, already building the telescopes and instruments that can detect oxygen, methane, water vapor in distant atmospheres. We're already designing concepts for interstellar probes, small spacecraft that could be accelerated to a fraction of light speed and sent to nearby stars within a generation or two. We're already imagining what it would take to become an interstellar species, and with that imagining comes responsibility, because if we visit another world, we'll carry with us all the lessons, all the mistakes, all the ethics we've developed here. We'll bring our curiosity but also our capacity for harm. We'll bring our desire to learn but also our tendency to take, to exploit, to prioritize our needs over the integrity of what we find. And we'll have to make choices about how we behave, choices that will define not just that mission, but what kind of civilization we are. Do we land on a planet with primitive life, single-celled organisms or simple multicellular forms, and risk contaminating it with Earth microbes? Do we prioritize scientific discovery over planetary protection? Or do we stay in orbit, observing from a distance, ensuring that what we find remains untouched, developing on its own path without our interference? And what if we find a planet with intelligent life? Not technological, not spacefaring, but intelligent. Beings that use tools, that communicate, that have culture. Do we make contact? Do we reveal ourselves, knowing that our presence alone might alter their development, might change the course of their history in ways we can't predict or control? Or do we watch silently, recording, learning, but never interfering, letting them evolve and grow and find their own way to the stars? These are the questions that visiting civilizations might have faced when they came to Earth, if they came, and now we're beginning to face them too. The roles are reversing. We're becoming the ones with the power, with the technology, with the responsibility to choose wisely. And how we answer these questions will say a lot about us, about what we value, about what kind of species we want to be. There's a humility in this reversal. Because when we imagine ourselves as visitors, when we think about what we do and how we do it, we start to understand why evidence of past visitation might be so scarce. If we're careful, if we follow protocols, if we respect the worlds we visit, we won't leave much behind either. A few sensor readings, maybe some chemical signatures if we refuel or conduct experiments, but nothing obvious, nothing that screams artificial. And after 1 million years, after erosion and geology and the slow turning of the planet, even those faint traces would be gone. So maybe the absence of evidence isn't evidence of carelessness or absence. Maybe it's evidence of care, of a decision to observe without interfering, to learn without leaving marks, to let Earth and its life develop naturally. And if that's true, if visiting civilizations practice the same caution we're beginning to consider, then the silence makes sense. It's not empty, it's respectful. There's also the possibility that we'll learn from our mistakes, that by the time we're capable of interstellar travel, we'll have already faced the consequences of interference here on Earth. We've seen what happens when one culture dominates another, when exploration becomes exploitation, when curiosity becomes conquest. We've seen ecosystems collapse because we introduced invasive species, because we took without understanding what we were taking. And maybe those lessons will shape how we approach other worlds. Maybe we'll develop a kind of cosmic environmentalism, a recognition that every planet, every biosphere, every potential civilization is valuable in its own right, not for what it can give us, but for what it is. And maybe that ethic, if we develop it, will guide us to be the kind of visitors who leave no trace, who observe with reverence, who protect what we find rather than claiming it. But we're not there yet. We're still learning. We're still struggling with how to care for our own planet, how to balance our needs with the needs of other species, how to think long-term instead of short-term. And until we solve those problems here, it's hard to imagine we'll be ready to take that care outward, to other worlds, to other forms of life. Still, the act of imagining it, of thinking through what we'd do and why, is valuable, because it forces us to confront our own motivations, our own ethics, our own capacity for both wonder and harm. It asks us to think about what exploration means, what discovery costs, what responsibility comes with knowledge and power, and it connects us, in a strange way, to the civilizations we've been wondering about. Because if they visited Earth, if they faced these same questions, then we're walking in their footsteps. We're going through the same process they went through, asking the same questions, struggling with the same tensions between curiosity and caution, between the desire to know and the need to protect. And maybe, in that shared struggle, we find a kind of kinship. Not contact, not communication, but a recognition that the path to the stars is difficult, and anyone who walks it has to grapple with the same fundamental choices. What kind of explorer do you want to be? What kind of visitor? What will you leave behind? And what will you take care to preserve? These questions apply to us now, here on Earth, as we decide how to treat our own ecosystems, our own planet. And they'll apply to us later, if we ever reach other worlds. The answers we give will shape not just our future, but our legacy. The story we tell about ourselves, written not in words but in actions, in traces, in the marks we leave or don't leave as we move through the cosmos. And as we think about all of this, as we consider the possibilities and the responsibilities, we come back to something fundamental, something that's been underneath this entire journey, the recognition that we don't know, that the universe is full of mysteries we haven't solved, questions we haven't answered, possibilities we haven't even imagined yet, and that not knowing, that uncertainty, isn't something to fear, it's something to embrace. Science is many things, a method, a body of knowledge, a way of approaching the world. But at its core, science is an act of humility. It's a recognition that the universe doesn't owe us understanding, that our intuitions can be wrong, that what seems obvious might not be true. It's a willingness to test, to question, to change our minds when the evidence demands it. And it's a comfort with uncertainty, with saying I don't know and meaning it, without embarrassment, without defensiveness. The question of whether Earth has been visited by extraterrestrial civilizations is, at its heart, a question about the limits of what we can know. We've looked at the evidence, or the lack of it. We've considered the challenges, the timescales, the ways that traces degrade and disappear. We've explored possibilities, from technosignatures in rock layers to artifacts on the moon, to genetic anomalies in our DNA. And what we've found is absence. Not proof of absence, but absence nonetheless. An empty space where evidence might be, or might have been, or might someday be discovered. That absence is frustrating. We want answers. We want to know, definitively, whether we're alone or whether we've been visited. We want the comfort of certainty, the clarity of proof. But the universe doesn't always give us what we want. Sometimes it gives us questions instead. And those questions, uncomfortable as they are, might be more valuable than the answers we're seeking. Because living with uncertainty teaches us something. It teaches us patience. It teaches us to hold space for possibilities without committing to them prematurely. It teaches us to distinguish between what we know and what we believe, between evidence and interpretation, between fact and hope. And it teaches us humility, the recognition that we're small, that our perspective is limited, that there's far more we don't understand than we do. The history of science is a history of humility. Every major discovery has involved overturning assumptions, admitting that what we thought we knew was wrong or incomplete. We thought Earth was the center of the universe. We were wrong. We thought time was absolute, the same for everyone everywhere. We were wrong. We thought the universe was static, unchanging. We were wrong. And with each correction, with each expansion of our understanding, we became smaller in the cosmic sense, but larger in our capacity to comprehend. The question of extraterrestrial visitation fits into this pattern. We assume we'd recognize evidence if it existed. We assume that absence of evidence means evidence of absence. We assume that the methods we've developed, the instruments we've built, the places we've looked are sufficient. But what if those assumptions are wrong? What if evidence exists in forms we haven't thought to look for, in places we haven't explored, in patterns we haven't learned to recognize? That doesn't mean we should believe without evidence. It means we should stay open, curious, willing to revise our understanding as new information comes in. It means we should keep looking, keep asking, keep refining our methods, and it means we should be comfortable saying we don't know, not as a failure, but as an honest assessment of where we are. There's beauty in that honesty, in admitting that the universe is bigger than our understanding, that mysteries remain, that some questions might not have answers, at least not yet. It's easy to mistake certainty for strength, to think that admitting uncertainty is weakness. But the opposite is true. Certainty can be brittle, inflexible, closed to new information. Uncertainty, held well, is flexible, adaptive, open. It allows growth. It invites discovery. And the question of whether we've been visited invites something else too. It invites imagination. Not in the sense of making things up, but in the sense of envisioning possibilities, of thinking beyond the immediate and the obvious. Imagination is how we explore territories we haven't reached yet, how we test ideas before we have the means to test them physically. It's a tool as valuable as any telescope or microscope for expanding the boundaries of what we think is possible. So we imagine what it would mean if Earth had been visited. We imagine the traces that might remain, the ways we might find them, the implications they'd have, and in imagining, we sharpen our thinking. We identify what we'd need to prove, what we'd need to rule out, what questions we'd need to answer. We prepare ourselves conceptually for discoveries that might never come, or that might come tomorrow. And that preparation is its own kind of value. But we also have to balance imagination with rigor, with the discipline to test ideas, to demand evidence, to reject explanations that don't hold up under scrutiny. Because imagination without rigor becomes fantasy. And fantasy, however appealing, doesn't lead to understanding. It leads away from it, into comfortable stories that might feel true but aren't grounded in reality. So we walk a line between curiosity and skepticism, between openness and rigor, between wonder and discipline. It's not an easy line to walk, It requires constant adjustment, constant attention. But it's the line where real science happens, where real discovery becomes possible, and it's the line where questions like this one, questions about visitation, about contact, about our place in the cosmos, can be held honestly, without collapsing into either dogmatic dismissal or credulous acceptance. And as we walk that line, as we hold the question gently, without forcing it toward an answer it's not ready to give, we find something unexpected. Not proof, not certainty, but connection. Connection to the vastness of space and time. Connection to the mystery that surrounds us. Connection to the act of wondering itself, which is, in its own way, a form of reaching out. Because we're not alone in asking these questions. People have been looking at the sky, wondering what's out there, imagining visitors and travelers and beings unlike themselves for as long as there have been people. It's part of what makes us human, this capacity to wonder, to reach beyond what we know, to ask what if. And whether or not Earth has been visited, whether or not we ever find proof, the fact that we ask, the fact that we care, connects us across time, across cultures, across the boundaries of what we understand and what we don't. So we rest here, in this space of not knowing, not because we've given up, but because we've accepted that some questions take time, that some mysteries don't yield easily, that the universe is patient and we need to be patient too. And in that patience, in that acceptance, there's a kind of peace. And so here we are, at the end of this long, quiet journey through time and possibility. We've wandered through billions of years, across the surface of our planet and beyond it, into the ocean depths and to the moon, through the layers of rock and the spirals of DNA. We've asked whether Earth, this small world spinning through the dark, has been visited by others, and the answer, if there is one, remains soft, uncertain, hidden in the spaces between what we know and what we wonder. Maybe they came, maybe civilizations from distant stars paused here, looked around, took notes, and moved on. Maybe they left traces so subtle we haven't recognized them, or so degraded that time has claimed them back. Maybe the moon holds secrets in its craters, or the ocean floor guards relics beneath miles of water and sediment. Maybe our DNA carries messages we haven't learned to read, or the rocks beneath our feet remember visitors we've forgotten. Or maybe they didn't come. Maybe Earth has always been alone, turning quietly in its orbit, hosting life that arose here and nowhere else, developing intelligence that's unique, at least for now, in this corner of the galaxy. Maybe the silence is real, the vastness is empty, and we're the first to look up and wonder if anyone else is out there. We don't know, and maybe we never will. Maybe the question is destined to remain open, a mystery that accompanies us as we grow, as we explore, as we eventually venture out to other worlds and become the visitors we've been imagining. Maybe the not knowing is part of the story, part of what makes us who we are, curious and small and reaching always towards something larger than ourselves. But even without answers, even without proof, the question has value. It connects us to the cosmos, reminds us that we're part of something vast and ancient and still unfolding. It humbles us, showing us how much we don't know, how much there is yet to discover. And it invites us to wonder, to imagine, to hold space for possibilities that might never become certainties, but are beautiful nonetheless. You've been part of this tonight, following these thoughts through the dark, letting your mind wander across distances and timescales that dwarf everything familiar. And in doing that, You've participated in something old and universal. The act of looking up, of asking questions, of reaching across the void with nothing but curiosity and hope. Whether Earth has been visited or not, whether we're alone or surrounded by distant neighbours, that reaching matters. That wondering connects you to everyone who's ever looked at the stars and felt the pull of something larger, something just beyond the edge of understanding. And now the night is here, deep and patient, ready to hold you as you let go of these questions, as you sink into rest. Sleep, after all, is its own kind of journey, a descent into layers, into dreams, into spaces where time moves differently, and the boundaries between what's real and what's imagined blur and soften. And maybe that's fitting, because the question we've been exploring exists in that same blurred space, between the known and the unknown, between the possible and the proven, between what we can measure and what we can only feel. So rest now. Let your thoughts slow down. Let your breathing deepen. Let the weight of the day and the questions and the wondering settle gently into stillness. The stars will keep turning. The galaxy will keep spinning. And whether anyone out there is watching, whether anyone ever visited, whether we're alone or part of a vast community of minds scattered across light years and eons, you're here now. You exist, you matter, and that's enough. The past will wait. The future will unfold in its own time. And for now, for tonight, you've carried these questions far enough. You've walked with them through the dark, through the layers of Earth's history and the depth of space, and now it's time to set them down. Not forever, just for a while. Because tomorrow, or someday, you'll pick them up again. You'll wonder again. You'll look up at the sky and ask what's out there. Who else might be looking back? Whether we've been seen by others the way we see the stars, but tonight you can rest with the mystery. You can let it be unresolved, unfinished, open. You can let the vastness be vast, the silence be silent, the unknown be unknown. And you can find peace in that, not because the questions are answered, but because they've been honoured, because you've given them attention, time, care. And that's a kind of connection too, a reaching out not to distant civilizations, but to the universe itself, to the strangeness and beauty of existence, to the simple fact that we're here, aware, wondering. So sleep well, traveller. Sleep well, explorer of questions and holder of mysteries. The cosmos is patient. Earth will keep turning. And somewhere, in the deep time that stretches behind us and ahead of us, in the vast spaces between stars, in the quiet moments when minds look up and wonder, you're part of something larger, something that doesn't need proof to be real, doesn't need answers to be meaningful. You're part of the wondering itself, and that's enough. Good night.